Hello children, welcome to Spark Physics by ASHISH Sharma sir, the easy and simple way to learn the concept of physics. Let us begin with the new topic of your unit, rotational motion. The unit is System of Particles and Rotational Motion. So far in the previous units, we have seen so many times we were using an object is moving from this point to this point, force applied on this object. We were not talking about the object. Okay, there we considered the object to be the point object. What is point object? I have already discussed earlier in previous videos. If the object covers very large distance as compared to the size of the object, then it is called point object. Point object का मतलब ये नहीं है कि वो point की तरह बहुत छोटा होगा. Earth can also be considered as point object. Why? Because during its rotation around the sun, the distance covered by the earth is very large as compared to size of the earth. Okay. So here in actual practice you will find कोई भी object है, it consists of so many particles. So here in rotational motion we will be considering when the object rotates around it any axis, all the particles of which it is made up of will be मूविंग अराउंड दैट एक्सिस. तो वो सारे पार्टिकल्स को यदि हम कंसीडर करेंगे, उनके मासेस भी डिफरेंट हो सकते हैं. देन हाउ वी विल मेक दैट दोज कॉम्प्लिकेशंस इजियर बाय यूजिंग द कंसेप्ट ऑफ सेंटर ऑफ मास ऑफ द ऑब्जेक्ट. व्हाट इज सेंटर ऑफ मास? इट इज द पॉइंट इन द ऑब्जेक्ट where whole mass of the object is supposed to be concentrated. क्या मतलब है? एक ऐसा पॉइंट हम लेते हैं ऑब्जेक्ट के अंदर जहां पर ऐसा मानकर चलते हैं कि सपोज देयर इज द मास ऑफ द ऑब्जेक्ट कंसंट्रेटेड, सारे पार्टिकल्स का मास एक ही जगह पर कंसंट्रेटेड है. यदि हम स्फीयर की बात करें, सॉलिड स्फीयर, राइट, एवरीवन नोज व्हाट इज सॉलिड स्फीयर. ओके, तो उसमें जो सेंटर ऑफ मास होता है वो सेंटर पे होता है. Okay, if we consider a ring, right, ring में भी center of mass की position center होती है, center of the ring, where if we see actually there is no mass of the ring at all. वहाँ कोई mass present नहीं होता है, लेकिन जहाँ हम मानकर चलते हैं कि concentrated है in the ring, it is the center, right? So when we consider cylinder, the center of the mass will be at the center of its geometrical axis. So this is all about center of mass. So we will find today what is the position vector of center of mass of two particle system. हम position कैसे calculate करेंगे? We will be deriving one formula to find the position of center of mass of the two particle system. That same formula we can extend for n particle system. Okay, so to begin with, you see I have made a diagram. Particle A of mass m1 is taken, particle B of mass m2 is taken. Their respective positions from origin O is r1 and r2. When we join this, these are the positions at any time t. Suppose ये जो दो पार्टिकल हैं जिससे ये सिस्टम बना है, इनका सेंटर ऑफ मास कहीं C पॉइंट पर है. आई एम नॉट सेइंग इट इज एट द सेंटर ऑफ द लाइन जॉइनिंग द टू, इट कैन बी एनीवेयर. वी विल फाइंड दैट वेयर इट इज. इट्स डिस्टेंस फ्रॉम द ओरिजिन इज RCM, राइट? CM वी आर यूजिंग फॉर सेंटर ऑफ मास. नाउ टू थिंग्स यू नीड टू टेक केयर हियर. जब ये दो पार्टिकल से मिलकर बना है, ऑब्वियसली दे विल बी एक्सर्टिंग फोर्स ऑन ईच अदर. F12 is the force on object A on the object A by the object B. F21 is the force on the object 2 by this one. Okay, these small F1, F2 I have considered the external force. Suppose object is acted upon by the external forces. तो दोनों particles पर A और B पर F1 और F2 external forces है, that I have written. Okay, so total force acting on the first particle, how much we can write? Let's see. Total force on particle ए, टोटल फोर्स हम कितना ले लें, सपोज F1 ऑन पार्टिकल ए, हाउ मच इट विल बी, कितना फोर्स लग रहा है, एक तो बी पार्टिकल ए पर एक्सर्ट कर रहा है, दैट वी कैन राइट F12 प्लस एक एक्सटर्नल फोर्स भी है जो हमने F1 लिखा है, राइट. दिस वी नो, this total force can be, we can find out by using, we will be applying Newton's second law of motion, F is equal to ma. But before that we will find total force F2 on particle B. कितना होगा, F2 will be equal to F21 plus F2. Okay, according to Newton's second law of motion, we have F is equal to ma. Therefore, this is say equation 1, this is 2. Equation 1 and 2 becomes, we can write m1 acceleration a1 on the first particle equal to f12 plus f1 and m2 a2 equal to f21 plus f2. This is equation 3, this is equation 4. We have taken particles separately, but we are talking about the system of particles, two particles का जो system बना हुआ है. So total force on the system, we will be adding equation 3 and 4. So m1 a1 plus m2 a2 will give you f1 plus f2 plus f12 plus f21. Okay, since f21 is equal to minus of f12. Why? Because equal and opposite forces exerted by 1 on 2 and 2 on 1. So therefore we can write m1 a1 plus m2 a2 equal to f1 plus f2. This will cancel, right? This will cancel. Suppose it is equal to f. This is equal to f. So we will have m1 a1 plus m2, this is not plus, okay, a2. This is the total force acting on the system. तो जब total force है, तो if we take total mass of the system, how much it is? Say capital M will be equal to m1 plus m2, right? If ACM be the acceleration of center of mass, then what we can write? F can be written as m a c m. टोटल फोर्स इतना लगना चाहिए, टोटल मास ये हो गया और एक्सेलरेशन ये हो गया, राइट? सो therefore this equation we can take 5 from equation 5. How much? MACM equal to, we have m1 a1 plus m2 a2. For accelerations, what we can write? We have discussed differentiation in second unit. क्या था? When we differentiate position vector, we get velocity. When we differentiate velocity, we get acceleration. That means if we differentiate position vector twice, we will get acceleration. Okay, so that means we can write m differentiation of this one, d square RCM by dt square by position vector of center of mass differentiating twice will give you this, right? So this we can write m1 d square r1 upon dt square plus m2 d square r2 upon dt square. This we will give. So from here m d square rcm upon dt square equal to, take vector sign, okay, d square by dt square, it is m1 r1 plus m2 r2. Second differentiation, second derivative here also. So this will give you rcm equal to m1 r1 m2 r2 upon m. Okay, this m we are taking the side. So this is the position vector of center of mass of two particle system, right? If there are n particles, then RCM we can extend m1 r1 plus m2 r2 plus mn rn upon masses, addition of the masses, right? This we can write sigma mi ri I equal to 1 to n upon sigma mi I equal to 1 to n. Can also be written as RCM equal to, this is nothing but total mass, so 1 by m, it will give you sigma mi ri I equal to 1 to n, right? This is the position vector for n particle system. So from this to this we have reached by using concept of differentiation. If we would want to write the velocity of center of mass, we can write it as m1 v1 plus m2 v2 plus mn vn. पोजीशन की जगह पर वेलोसिटी लिख देंगे एंड यू विल गेट द रिजल्ट. Okay, I hope derivation very easy, it is clear to you. We will be discussing now how we can write this in Cartesian coordinates, and if the mass distribution is continuous, what is the formula? Direct we will deal with. Okay, let's have a look on it. So when comes to Cartesian coordinates, you can write for x coordinate, y coordinate, z coordinate. Instead of positions r1, r2, r3, we have taken x1, x2 and so on up to xn. This capital M I have directly written for the total mass m1, m2, m3 and mn. Y coordinates m1 y1 plus m2 y2 plus mn yn upon total mass. Z coordinate m1 z1 plus m2 z2 plus mn zn upon total mass. If the mass distribution is continuous, तो कैसे लिखेंगे? For center of mass position vector is 1 upon m. Basically it is divided by total mass. जैसे यहाँ पर divided है वही है, that is taken out 1 upon m. Integration r dm. What is r dm here? R is the position vector. किसका? dm. dm is the mass of the small element located at position r. r position पे जो small element है. This we can take when mass distribution is continuous. You will find this formula is applicable when we will be finding the center of mass of uniform rod, right? We will directly apply this formula and we will get the result. In the next video, we will be doing important questions on center of mass and we will be finding center of mass of the rod, uniform rod. I hope the concept is very much clear to you, dear children. Work hard, do well. Thank you for watching this video till the end. Don't forget to like, share, subscribe और comment करना तो भूलना नहीं है. Thank you once again.